Okay guys, welcome to your video on section 8.4. We're going to start a two-lesson discussion on the concept of a vector. And so you can see here that we have a definition for a vector. A vector is a quantity that has both magnitude and direction. And it's customary to represent a vector using an arrow where the length of the arrow represents the magnitude of the vector, and then the arrowhead represents the direction of the vector. And a lot of the times we will talk about vectors in terms of initial points or where the vector starts, and then terminal points where the vector ends. And so in example 1, 2, and 3, we're going to practice drawing vectors. And so I'm going to show you exactly how this is done whenever we add two vectors, in this case, v plus w. So if I want to add v plus w, here's exactly what I do. I start with a copy of the vector v. So just as best I can, I'm going to copy vector v. I know my v is a little longer than the v that was given in the problem, but that's my best attempt. What I'm going to do next is I'm going to start at the tip of v, which would be right here, of course, and I'm going to basically glue on a copy of w to that. And so here is my copy of the vector w. And then v plus w connects the initial point of v, which is right here, to the terminal point of w, which is right there. So I'm going to do this in a different color. This is going to be my vector right here of v plus w. Okay, example 2, we want to use the vectors to draw 2v, and so what that 2 does in front of the v is it just changes the magnitude of vector v. It does not change the direction, so 2v is still going to point in the downward direction, but it's going to be twice as long as vector v is. And so 2v will be however long v is and then double it, and that's how we'll get the vector 2v. Okay, Siri wants to get in on the video. Example 3, we're going to subtract two vectors, and when we do this, it's a lot like adding a negative. And so we're going to really think of this as being like v plus negative w, where negative w is the same as w, just in the opposite direction. And so once again, I'm going to start with a copy of vector v, and then I'm going to add to the end of that a copy of negative w, which instead of pointing up and to the right, like this vector is doing right here, negative w is going to point down and to the left. So here's my negative w right there. And then again, just like before on example 1, the resultant vector, or the answer, if you want to think about it like that, will start at the initial point of v and point to the terminal side of negative w. So this is my v minus w vector right here. Okay, before we get to example 4, we're going to talk about some properties of what's called the magnitude of a vector. And so the magnitude of a vector is denoted by this symbol right here. It kind of looks like double absolute value bars, if you want to think about it like that. And it is the length of a directed line segment, and therefore it follows the following properties. First of all, magnitude always has to be greater than or equal to 0 because a magnitude represents a distance. That distance is equal to 0 if and only if we're talking about the 0 vector. The magnitude of the opposite of v has to equal the magnitude of regular v, which should hopefully make sense because the negative just changes the direction, it doesn't change the length. And then if we take a vector and multiply it by some constant alpha, then the result is going to be the absolute value of alpha multiplied by the magnitude of v. Okay, so in example 4, we're given that the magnitude of vector v is equal to 8. And we want to know what is the magnitude of 4v. So that's going to be using our fourth property here. And so I see that this magnitude of 4v is going to equal to the absolute value of that constant 4 multiplied by the magnitude of v. And we know that the absolute value of 4 is 4. We were given that the magnitude of v was equal to 8. And so the answer here is going to be 32. Okay, in example 5, what we're going to do is we're going to take 2 points, a an initial point and a terminal point and create a vector or a position vector from those points. So the formula to do that is listed right here. I'm going to erase that just so that you can see it again. But basically what we're going to do is we're going to take the difference of the x-coordinates, and that's going to be our first component of our vector. And the second component is going to be the difference in the y-coordinates of those points. And then I'm going to introduce this new notation, this IJ notation that's really common in physics and some other application fields. And so that really just means that your ith component is your first component and your jth component is your second component of your vector. Okay, so we have the vector v has initial point 6, 6 and terminal point q of 9, 5, and we want to write the vector v in the form ai plus bj, and what that means is to find its position vector. So I'm going to start by writing that the vector v is equal to, and then I like to use this shamrock notation. This symbol right here is called a shamrock. It kind of looks like a less than or a greater than sign. And for the first component, or the x component of this vector, we're going to take the x-coordinate of the terminal point, which would be 9, and subtract the x-coordinate of the initial point, which would be 6. So you always want to do terminal minus initial. You never want to do initial minus terminal. That would not be the correct way to do that because your vector will be pointing in the wrong direction. So you always want to do the terminal point minus the initial point. For the y-coordinate, we're going to do the same thing just with the y-coordinates. And so this will be terminal point, which is 5, minus initial point, which is 6. Just doing some simplifying, that's going to give me 3 and negative 1. And so writing this in AI plus BJ notation, this is going to be 3 multiplied by I minus 1 multiplied by J. Okay, in example 6, we're going to learn how to find the magnitude of a vector if you're given its two components. And this is going to look a lot like finding the radius of a complex number that's in polar form or in complex form. So it's just the square root of a1 squared plus b1 squared. So the square root of the first component squared plus the square root, the second component squared. So in letter A, if I want to find the magnitude of vector v, then this is going to equal to the square root of the first component squared plus the second component squared. And calculating the number under that square root is going to give me 100. And of course, I know that the square root of 100 is equal to 10. Okay, letter B, I'm going to do the exact same thing. So this is going to be the magnitude of v is equal to the square root of the first component squared plus the second component squared. And calculating that number underneath the radical, you're going to get 162. And you're going to need to simplify that number for your final answer. So what's the biggest perfect square that goes into 162? That would, of course, be 81 multiplied by 2. And then the 81 will come out of the radical and become its square root, which is 9. The 2 has to stay underneath since it is not a perfect square. Okay, examples 7, 8, and 9 are going to just be more properties here that we are going to practice. And so this says to find 4v plus 5w given the vector v and the vector w. So what I'm going to start off by doing is figuring out what 4v is. And this is just equal to 4 multiplied by the vector v, which I like to write in this shamrock notation. And so that would be 5 comma negative 7. And when we multiply a vector by a scalar or by a constant, we just multiply both components by that constant. So the first component is going to be 4 times 5, which is 20. And the second component will be 4 times negative 7, which is negative 28. Okay, then I am going to find what 5w is, and 5w is going to equal to 5 multiplied by the vector negative 4 and 3, which is going to equal to 5 times negative 4, which is negative 20, and 5 times 3, which is 15. And then the problem tells me to add these two things together. So if I were to add these together, then my first component or my x component would end up being 0, 20 plus negative 20, and my second component would be negative 28 plus 15, which will be negative 13. And writing that in ij notation, I'm going to have 0i, which I don't really need to write down, minus 13j. And that's how you're going to want to answer on your online homework. Make sure that you're reading the directions. Okay, in example 8, we want to find the magnitude of v minus w. So the thing that we need to do first is figure out what v minus w is. And so v minus w is going to be the vector negative 6 and 2 minus the vector 6 and negative 4. And whenever we subtract vectors, we just subtract their components. And so if I look here, I've got negative 6 minus a 6, which is going to give me negative 12. And then I have also got a 2 minus a negative 4. Be really careful there to have the correct signs. And so that would be positive 6. Okay, if then I want to find the magnitude of that new vector, v minus w, then I'm just going to use the method that we learned in example 6, which is to take the square root of the first component squared and add that to the second component squared. And typing that into the calculator to get the number under the radical is going to give you square root of 180. And the biggest perfect square that will go into 180 would be 36, and I believe 36 times 5 is going to give you 180, and so the 36 gets to come out and become a 6, and the 5 has to stay underneath since it is not a perfect square. Okay, in example 9, this is a little different than example 8. Notice here I want to find the magnitude of v, and I want to subtract it from, or do minus the magnitude of w. So the thing I'm going to do first is find the magnitude of v, and so that's going to be the square root of 3 squared plus negative 5 squared, and doing the arithmetic there is going to give me square root of 34. I'm then going to find the magnitude of w, which will be the square root of negative 6 squared plus 6 squared, which is going to equal to the square root of 72, which can be simplified because I know that 72 is 36 times 2, which is going to give me 6 square roots of 2. So now, whenever I do the magnitude of v minus the magnitude of w, this is just going to equal to the square root of 34 minus 6 times the square root of 2. Okay, in example 10, I'm going to teach you how to find what is called a unit vector. And so notice that for a unit vector, the definition of that is that the magnitude is equal to 1, and we want the unit vector to have the same direction as the given vector, vector v. And so the formula to do this is given right here. We're going to take the given vector v, and we're going to divide it by its magnitude. Okay, so here we go. On letter A, the first thing we need to do is find the magnitude of this vector v. And so this will be the square root of the first component squared, which will be 7 squared, plus the second component, which is 0, since there is no j component there. And so this ends up being the square root of 49, and the square root of 49 is 7. Okay, so therefore, my unit vector, which we'll call u, which is going to be v divided by the magnitude of v, is going to be 7i divided by 7, and the the 7s are going to cancel, and so that's just going to give me the vector called I. Okay, letter B is very similar to this, and so first things first, we want to find that magnitude just like we did before, and so this is going to be the square root of negative 8 squared plus the negative 6 squared. Putting that into your calculator, you're going to get 64 plus 36, which will end up being 100. And so this is going to equal to a magnitude of 10. And so therefore, my unit vector, which is going to be v divided by the magnitude of v, will be negative 8i minus 6j divided by 10. And we do want to go ahead and simplify that by splitting through the numerator like we normally do. So negative 8 divided by 10 is going to reduce to negative 4/5 multiplied by I, and negative 6 over 10 will reduce to negative 3 over 5 multiplied by j. Okay, I'm going to give you a chance to do letter C on your own, so if you'd like to pause the video and give that a shot, then now is the time to do that. And hopefully what you got for u is equal to 1 over the square root of 5, multiplied by I, and then minus 2 over the square root of 5 times j. Okay, in example 11, sort of a word problem here. So we're going to find a vector v whose magnitude is 9 and whose component in the I direction is twice the component in the j direction. So what we're trying to do is we're trying to find a vector v, and I'm just going to start off by saying that v is equal to the vector AB. And my objective now is to figure out what A and B are. Okay, so what this tells me is that the magnitude of vector v is equal to 9. So I know that the magnitude of vector v is going to equal to the square root of a squared plus b squared, and that tells me that this should equal to 9. If you square both sides of that equation, what you're going to get is that a squared plus b squared has to equal to 81. Okay, so that's using the first part of the problem in order to set up an equation. Now I'm going to use the second part of the problem, which is starting with whose component in the I direction. Well, the component in the I direction, I've called it A, is twice the component in the j direction, which is called b. So we now have the second equation, a is equal to 2b, and I'm now going to be able to substitute that into my first equation. So when I do that, doing the algebra, this is going to be 2b squared plus b squared is equal to 81. When you square 2b, you end up with 4b squared plus b squared is equal to 81. Combining the like terms will give you 5b squared is equal to 81, and this is going to allow us to solve for b. So b squared is going to equal to 81 over 5, which means that b is going to equal to the square root of 81 divided by the square root of 5, which means that we're going to have square root of 81, which is 9, divided by the square root of 5. Okay, once I have once I have b, I am now able to take that and go back up here in order to get a, and so a is going to equal to 2 times 9 over the square root of 5, which will be 18 over the square root of 5. And how we want to write our answer is in IJ form. And so I'm going to put my answer right here. This will be 18 over the square root of 5 times I plus 9 over the square root of 5 multiplied by j. Okay, example 12 and 13, it says we can also write a vector using the following, and this is going to look a lot like polar form, except it's not imaginary, so don't really think about it in that term, but the formula is very similar. So write the vector v in the form ai plus bj, given its magnitude and the angle that it makes with the positive x-axis. Okay, so we're going to say here that v is equal to, starting with the first thing in our formula, the magnitude of v, which they say is equal to 9, multiplied by the cosine of the angle alpha, which is 60 degrees, multiplied by I, plus the sine of the angle alpha, 60 degrees, multiplied by j. Okay, I need to know my unit circle values now, so cosine of 60 degrees is going to be 1/2 multiplied by I, and sine of 60 degrees is going to be the square root of 3 over 2 multiplied by j. And the thing that I'm going to do to finish this problem off then is just to distribute my 9. And so that's going to end up giving me 9 divided by 2i plus 9 square roots of 3 divided by 2 times j. And if anything in that fraction could reduce, you would need to go ahead and reduce it. And we're going to see that happen in letter B. So I'm going to give you a chance to try letter B. And so if you want to go ahead and pause the video, you can try that out right now, and then I will come back and work it out for you. Okay, so for letter B, we've got v is equal to the magnitude of v, which is 4, and then cosine of 120 multiplied by I, plus the sine of 120 multiplied by j. Okay, so using the unit circle values, cosine of 120, well, I know that cosine is in quadrant 2, and that therefore it is going to be negative because cosine is negative in quadrant 2. The reference angle is being compared to 180 degrees, which is going to be 60 degrees, and cosine of 60 degrees is 1/2. So cosine of 120 will be negative 1/2. Sine of 120 is going to be positive because it's in quadrant 2, and sine is positive in quadrant 2. Again, the reference angle is 60, and sine of 60 is square root of 3 over 2 multiplied by j. Now, when I distribute my 4 this time, it's going to cancel with the 1/2. So this is going to be 4 times negative a half, which will be negative 2 times I, and then plus 4 over 2 reduces to 2 square root of 3 multiplied by j. Okay, example 13, our final problem for this section. Find the direction angle of V for the vector 12i plus 12j. And so this is going to be done very similar to what we did with complex numbers in an earlier section. This will be tangent inverse of b divided by a. And in this case, a and b are both 12, so 12 divided by 12 is going to equal to the tangent inverse of 1, and this is going to be in degree mode. And so in degrees, what angle has a tangent value of 1? That would be 45 degrees. Okay, any questions on section 8.4? Please don't hesitate to reach out and ask. Hope you guys have a great day.